Hello, this is going to be for ADJ2 assignment problem number 3. And for that problem statement, it's going to be for the following fragment of code. What page replacement scheme are you going to choose for this given code? Our choices are first in, first out, operational replacement, least recently used, or less recently used, and most frequently used. And this is kind of our code, and it's basically going to check if two matrices are the same. So let's jump into a little bit of the background. So we just described them earlier. First in, first out is a page replacement algorithm that replaces the oldest page for a new page when there is not enough space in the registers. So just replaces the last or the oldest one. Optimal replacement scheme is where it will check if a new page will be used in the future or down. Notices a page that won't be used, it can swap that page out with a new one that will be used. The hopes here is limit the number of page faults by peeling down the list of what pages will be used and planning accordingly. So it kind of peeks at the list or the numbers of what pages are going to be used in the future, and then it smartly tries to be like, okay, well, which ones I'm going to switch out that'll give me the least amount of page faults, which we'll explain that a little bit later. Least recently used is the page replacement algorithm will remove the page that it hasn't been used the longest. And then MFU, or most frequently used, is exact opposite, which will remove the page that is used most frequently. And I'm guessing it's because, like, oh, if it's used a lot, I guess it's not going to be used in the future. That's what I think there is. Then there's a important thing about Ability's anomaly. Hopefully I'm saying that right. This is for some page algorithms, when the number of pages increases, the number of page fault also increases. So we want to prevent that because page faults are bad. Page fault is when a page is not already loaded into main memory and it will need to be grabbed from long-term memory or memory storage and moved into main memory. This would be a page fault. If a process goes to load a page and it is already in main memory, then that is not a page fault. So that's good. So the requirements: we need to create a page replacement algorithm that best fits our given code, prevent as many page faults as possible for performance, and compare two matrices where the data could be wide-ranging. The justification methodologies, which we're going to use, is just we'll judge the page replacement algorithm based off performance, number of page faults, and then also if they suffer from Beldy's anomaly, they're probably already going to be canceled out because that also affects performance. So jumping into analysis, we use kind of this little example pages that would be loaded into memory. We have 3 registers, so it would be popped in one by one. And then depending on which algorithm, we would get hits for page faults. And so, excuse me one moment. So the more stars, which equates to a page fault, that's bad. So the more is bad, less is good. And for our first one, first in, first out, we're going to have 6 page faults with our data right here, and it also does suffer from Beldy's anomaly. So basically, if you add more, say if like the number of pages was n, if n gets greater, then also the page faults will also get greater. Then operational placements, which was one of our best ones, only had 4. And the thing is, the way this one does is, like I said, it peeks out into the future and says, okay, well, I have to make room. Am I going to need this in the future? And then if there's one that's not going to be used in the future, it'll kick that one out. So it's kind of smart. The problem is you have to know what's going to be used. So that might be difficult for ours because there are 2 matrices. So I'm not like it doesn't make sense to me how you would know what they are, but you're also doing a method to compare them. But yeah, we'll get in that. Least recently used, which I thought would be really good. It also had the same exact score as first in, first out, but it also could be specifically for that small sample size for example page. And then most recently used had 4, so it actually was another really good one. And so for final or justification summary, use analysis, it would be beneficial to use either OPR or MRU page replacement algorithm because those had the fewest page faults in our example test. OPR does not seem possible. I had discussed this earlier, as you'd have to know the pages beforehand, and that would be the matrices. Like I said, to me, it doesn't make sense because, like, if you knew them, why would you want to be comparing them? You could do something beforehand. With the OPR being dropped, it would be between LRU and MRU, and because they don't suffer from Beldy's anomaly. So my final choice was most recently use. Yeah, because specifically it got the best scores on our page fault kind of example counter. And honestly, I mean, it could be LRU or MRU, but we're going to go with MRU because it scored the highest in our example and because it doesn't suffer from Beldy's anomaly. And also because I don't think for this specific code, I don't think OPR is going to be valid because I don't think we're going to know ahead of time what are all the pages we're going to be used because we're comparing them. So I feel like we're going to figure that out. Anyway, so that MRU's final answer. Appreciate it.